Blockchain is a term that's become increasingly familiar in recent years, often mentioned in the same breath as cryptocurrencies like Bitcoin and Ethereum. But what exactly is blockchain, and why has it captured so much attention across industries far beyond finance? At its core, blockchain is a type of digital ledger, a record-keeping system that's fundamentally different from traditional databases. Imagine a ledger, like one you might use to track expenses, but instead of being stored in a single location or controlled by a single authority, this ledger is duplicated across a vast network of computers. Each participant in the network has access to the entire ledger, and every time a new transaction occurs, it's recorded in a way that's transparent and nearly impossible to alter retroactively. The name blockchain comes from the way information is stored, in blocks that are chained together in chronological order. Each block contains a list of transactions, a timestamp, and a unique code called a cryptographic hash. This hash not only identifies the block, but also links it to the previous block, creating a chain. If someone tries to tamper with a block, its hash changes, breaking the chain and alerting the network to the alteration. This structure makes the blockchain significantly secure. To successfully change a single record, an attacker would need to alter not only one block, but also every subsequent block on every copy of the distributed ledger across the network. For large and established blockchains, this is nearly impossible due to the enormous computational power required. The first and most famous application of blockchain technology is Bitcoin, introduced in 2009 by an individual or group using the pseudonym Satoshi Nakamoto. Bitcoin's blockchain functions as a public ledger for all transactions related to the cryptocurrency, allowing people to send and receive money without the need for a central bank or payment processor. This decentralized approach has been revolutionary, providing a new way to transfer value over the internet. But blockchain's potential extends far beyond digital currencies. Its ability to provide a secure, transparent, and tamper-resistant record has inspired applications in a wide range of fields. In supply chain management, for example, blockchain can be used to track products from their origin to the consumer, increasing transparency and reducing the risk of fraud. In healthcare, patient records stored on a blockchain can be securely shared among providers, improving care while maintaining privacy. In voting systems, blockchain could make elections more transparent and resistant to manipulation. Smart contracts are another innovation made possible by blockchain. These are self-executing agreements with the terms directly written into code. When certain conditions are met, the contract automatically executes, removing the need for intermediaries and reducing the potential for disputes. Platforms like Ethereum have popularized smart contracts, enabling a new generation of decentralized applications, or dApps, that operate without a central authority. Despite its promise, blockchain technology faces several challenges. One of the biggest is scalability. As more people use a blockchain, the network can become slower and more expensive to operate. For example, Bitcoin's network can handle only a limited number of transactions per second, leading to delays and higher fees during periods of high demand. Developers are actively working on solutions, such as the Lightning Network for Bitcoin and various upgrades for Ethereum, to increase transaction capacity and speed. Another issue is energy consumption. Many blockchains, including Bitcoin, rely on a process called proof of work to validate transactions and add new blocks to the chain. This process involves solving complex mathematical puzzles, which requires significant computational power and, consequently, a lot of electricity. Some newer blockchains use alternative methods, like proof of stake, which are much more energy efficient. Security is both a strength and a challenge for blockchain. While the technology itself is difficult to hack, vulnerabilities can exist in the applications built on top of it, such as cryptocurrency exchanges or smart contracts with poorly written code. High-profile hacks and scams have resulted in the loss of millions of dollars, underscoring the need for rigorous security practices and ongoing innovation. Regulation is another evolving area. Governments around the world are grappling with how to oversee blockchain-based activities, particularly in finance. Some have embraced the technology, seeing it as a driver of innovation, while others have imposed strict regulations or outright bans, citing concerns about money laundering, tax evasion, and consumer protection. Looking to the future, blockchain is likely to become an increasingly important part of our digital infrastructure. As the technology matures and becomes more user-friendly, we may see it integrated into everything from banking and insurance to voting and identity management. The rise of decentralized finance, or DeFi, is already challenging traditional financial services by offering lending, borrowing, and trading platforms that operate without banks or brokers. Non-fungible tokens, or NFTs, have brought blockchain into the worlds of art, music, and entertainment, allowing creators to sell unique digital items with verifiable ownership. Meanwhile, central banks in several countries are exploring digital currencies that use blockchain technology, aiming to combine the benefits of digital payments with the stability of government-backed money. For businesses, blockchain offers opportunities to streamline operations, reduce costs, and build trust with customers and partners. For individuals, it promises greater control over personal data, new ways to participate in the global economy, and tools to protect privacy in an increasingly connected world. Yet, as with any transformative technology, blockchain's ultimate impact will depend on how it's implemented and governed. Collaboration between technologists, policymakers, businesses, and communities will be essential to realize its full potential while addressing risks and ensuring that its benefits are broadly shared. In summary, blockchain is more than just the backbone of cryptocurrencies. It's a foundational technology with the potential to reshape industries, empower individuals, and redefine how we exchange value and information. As we continue to explore its possibilities and navigate its challenges, one thing is clear: blockchain is poised to play a significant role in the digital future.